So I'll start by drawing a picture here. It's not a bad idea to make a sketch of these things. The parabola starts 4 high and it's negative, so it's going to go like this. And I'm looking at the point at 1, 3, so let's say that one there. And if that's my tangent line, this shaded area in here is what we're trying to find. Okay? So I'm going to erase those marks just to keep a clear picture. But let's walk through it then and figure out how we could do this. To calculate the area of this triangle, so here's my triangle in red, I need to know the base and the height. So can anybody think of a way to figure out the base of this triangle? Sure, you, Sam. Yeah, the x-intercept here is going to be the base. How could I figure out the height? Yeah, y-intercept. So that's what we need to figure out, is what's the x and y-intercept. We can't do that without an equation. We need to know what this line is. So how would we do this? Well, I've started with a point. If I have a point, what else do I need to know to get the equation of a line? The slope. Yeah, so point plus a slope. Okay, how can I use the information in this problem to figure out the slope? In this class, when you hear slope, something should jump at you right away. You hear slope, you should think derivative. Good. So tell me about it. What's the derivative for this graph? So what will the slope be at that point? Yeah. So now I know the slope, and I also know the point. So I'll use this formula to figure out the equation. So I've got, let's see, y minus 3 equals negative 2 x minus 1. And if I do some rearranging, this is the equation that I end up with. So that means right away I can see that this intercept here must be 5. So I know the height equals 5. How do I figure out the x-intercept? I have to put in y equals 0. So 0 will be negative 2x plus 5. So I end up with 5 over 2. So I know the base is going to be equal to 5 over 2. The area will be 1/2 the base times the height. This is 1/2 of 5 times 5/2, which is 25 over 4. And that would be E.